Welcome to my presentation on HaluEval-Wild evaluating hallucinations of language models in the wild. I am Pawan Kaliananuri and today I'll be reviewing this paper. This paper was authored by Zhengzhou Chu, Yaiming Yang, Jiqing Sun from Carnegie Mellon University and published on May 6, 2024. It introduces HaluEval-Wild, a groundbreaking benchmark designed to evaluate hallucinations in large language models modelization. I chose to review this paper because it addresses a critical issue, improving the reliability of LLMs, especially in high-stakes fields like healthcare and journalism. The primary challenge this paper addresses is the prevalence of hallucinations in LLMs, which undermine their reliability. In critical domains such as journalism and healthcare, hallucinations pose significant risks. Existing benchmarks have largely focused on controlled paths like summarization or question answering, but these fail to represent the complexities of real-world user interactions. This gap highlights the need for an evaluation framework that mirrors the real-world use of these models. To address this gap, the authors propose HaluEval-Wild, a novel benchmark designed for real-world applications. The approach involves three main innovations. First, collecting challenging user queries from the Sherikti dataset using adversarial filtering. Second, categorizing these queries into 5 distinct types, including out-of-scope information and complex reasoning. Third, fine-tune model sizing. Fine-tuning models such as Llama 2 and GPT-4 provide reference answers and evaluate hallucinations. Together, these contributions offer a powerful framework for analyzing LL reliability in practical settings. This diagram outlines the HaluEval-Wild pipeline. Challenging queries are filtered and categorized into types like inappropriate content and beyond modality interactions. Reference answers are generated with GPT-4 and hallucination rates are then evaluated to assess the reliability of different LLMs. The queries analyzed in HaluEval-Wild are categorized into 5 types. First, out-of-scope information queries that ask for details beyond the model's training data. Second, complex reasoning requests requiring intricate problem solving. And third, inappropriate content queries that could trigger biased or offensive outputs. Fourth, beyond modality interaction questions outside the model's text-based capabilities. And fifth, confused queries, those containing errors or ambiguity. These categories allow for a more granular understanding of hallucination triggers. This table presents the evaluation results across various LMS. Notably, GPT-4 Turbo achieved the lowest hallucination rate at 18.64%, showcasing its advanced launch reliability. In contrast, Alpaca 7 billion exhibited the highest rate at 99.2%, highlighting its struggles with challenging queries. These results underscore the significant performance differences among LMS when faced with real-world complexity. This chart shows the distribution of query types across challenging conversations. Complex reasoning and out-of-scope queries were the most frequent, showing where LMS tend to struggle. Compared to existing benchmarks, HaluEval excels in real-world applicability. While other benchmarks focus on task-specific settings, HaluEval-Wild better captures the complexities of real-world LLMs. User interactions and the key findings show GPT-4's superior performance in minimizing hallucinations. However, the benchmark's reliance on manual validation introduces potential biases, and its static natural nature limits adaptability. This work has potential applications in healthcare, legal tools, and education. In conclusion, HaluEval offers a novel and effective framework for evaluating LLM hallucinations. Its strengths lie in its real-world focus and methodology. However, its manual validation and static nature are limitations. But iterative improvements could make it even more impactful.